So today, the Honor Geometry Thursday, the 23rd of January. SWBA students will be able to use AAS, ASA, and HL to prove triangles congruent. Section 5.5. This is actually our last section as well, guys. Heads up, okay? This is our last section as well. Meaning what's probably coming up sometime soon. Probably a test. Okay. We have this class Monday, Wednesday, Friday next week, okay? We're looking to review Monday and test on Wednesday, my dudes, okay? A week from yesterday. Okay, so heads up on that. Okay? So yes. That doesn't have to be a compliment, but I guess. Okay. So last time we talked about how we can have these different triangle shortcuts. We can have these triangle shortcuts. We talked about side, 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 and side, angle, side. Okay, we talked about those being shortcuts that you can use to try and congruent. Because we said, oh, if we know this, that's actually enough information. Because it's not possible to have those things in common, those things congruent. It's not possible to have those things congruent and then not have congruent triangles. It's not possible, okay? So if we have that, we have to have congruent triangles. Okay? Stand in the corner. Okay? Yes, this is from before, this isn't real right now, okay? So, alrighty. Don't speak very okay? So, good call, okay? So let's explore a couple other options here. Okay, let's say, for example, that we have
It is actually kind of warmer over here. Not even gonna lie.
well, I mean, that's the corner for you, you know? Okay? So I'm going to copy and paste this triangle here. Oh, come on. Don't be telling me.
You might have to hold down.
No. But, like, I am.
You're not doing a very good job of it.
My goodness
No, we're not.
gracious. Oh, because I didn't have this one. Oh, my goodness. There we go.
There you go.
All right. I was hoping it wouldn't be temperamental today, but then it decided to be temperamental today. Just use the what? Give me the top one. Goodness gracious, this thing is not going to be cooperative with me. Okay? Now, I know I'm working on it. Okay, so let's say we start off, and in this time, let's make sure that we have these top angles congruent, okay? We're trying to see, are there any other shortcuts we can use, okay? Because not every possible combination might work, okay? Let's say, is this a shortcut we could use, okay? So we have these two angles, okay? Let's say these two angles are also going to be congruent. Okay, let's say hypothetically we have those two pairs of corresponding congruent angles. Now let's say we have this set of sides. Well, let's ask ourselves a question. Is that enough to prove the triangle is congruent? So we say, okay, well, is there a way we can adjust this triangle on the right here where my cursor is at? Okay, we can adjust this triangle on the right to where the angles and these two angles and this side don't change, but to where they're not congruent anymore. So we'd have to adjust these side lengths, wouldn't we? Okay, or we'd have to adjust this angle. Well, actually, could we even adjust this angle?
No.
What do we know about these two angles? They have to be congruent too, right? By our third angles theorem. If two sets of corresponding angles aren't congruent, the thirds have to be congruent. So if we try and adjust this, and I try and drag this out now, but I want to keep that angle the same, but I make it longer, and this one I have to keep the angle the same too. So can I swing it and keep the angle the same? No, I can only make it longer or shorter. But if I make this one shorter, is this even a triangle anymore? No. Okay. So if I go over here and I go back to what it was, and if I try and make this one shorter, that doesn't help either. If I try and swing it, well, that's changing the angle now. So is there any way that I can have this set up and them not be congruent? No, we're not seeing a way that we can manipulate this to where, oh, if I change up this side and make it longer, well, that is not part of the triangle. Okay, make sure. Well, it's not a triangle then anymore at all. So we have also that not only do we have the side, 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 and side angle side, we also have, what do you think this one would be called? Angle, side, angle. Now, where is the side on this one, guys? Is it just any random side?
No.
It's the included side here, isn't it? Okay, it's the included side. It's the side between the two angles, okay? The side between the two angles. And again, that leads us into our first triangle congruence for today, our triangle congruence shortcut for today, angle, side, angle, ASA. So it says if two angles and the included side, jeepers, and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Okay? So same kind of thing as side, angle, side, it's just kind of reversed. Instead of side, angle, side, it's angle, side, angle. Two angles in the included side. So if we go to number, I would say number A, but that's not true. Go to letter A. Can we determine if these two triangles are congruent? Do we think we have enough information? Okay, here's all says no. Okay, what do we know about this triangle? These two triangles. Let's start off with let's start off with saying, let's figure out all the information we possibly know, and then determine if that's enough. Okay. Okay, what's one thing we know?
It has one equal angle.
Yeah, angle C and angle F are congruent, right? They're both 61 degrees. Okay. Great. What's another thing we know?
Line DF and line AC are congruent.
Yeah, line DF, line AC are congruent. Okay. Do we know anything else? No, Amber. Okay, you can figure out angle B, right? How do we figure out angle B?
Add up 45 and 61.
Okay, 45 and 61. Okay, 106, then what? 180 subtracted by 106. What do we get? 74 degrees. And what do we notice now? Oh, they're congruent. Angle B and E.
So
So that
this
means
is a
A and
congruent.
D get congruent.
So that means A and D are, right now, is this enough information to prove these triangles congruent?
Yes.
No.
No.
No, because it's two angles and the what kind of side?
One side.
Non-included.
Yeah, but if it's the second,
But-
two are congruent, the third is congruent.
Exactly, but because two angles are congruent, the third angles have to be congruent. Now do we have two
Yes.
angles and the included side?
Yeah.
Yes, okay? So you have to go through that process there and make sure we have the included side there, okay? So
Oh, they have to
actually,
be in one row. I figured it out.
yeah, they have to be all connected.
I got it.
So like you can't just like skip over, okay? You can go skirt, okay? So we can do triangle, CBA. Let's group the triangle what? Go on one CBA, what do we call the other one?
FED.
Very good, FED. I have to go one arc, two arcs, three arcs if I can. Okay? And by what today? Angle, side, angle, right? Okay. So at first we looked at this and we said, no, we can't prove congruent. Okay, we saw one set of angles, we saw one set of sides, and that's all we saw. We said, well, there's no angle side or side angle. Okay? There's no as or saw. Okay? But once we dug into it a little bit more, we said, oh wait, well we can figure out this, we can do this. Oh, now we know. Okay?
No, we don't.
English next.
Oh.
Okay.
How you're reacting, I assume you didn't do the study guide.
Did you
By how
do this
you're
one?
reacting,
Nope.
Exactly. I did the study guide,
I
but.
didn't do this.
Let's look at example B. Let's look at example B. Okay? Why don't you guys actually try this one? Why don't you guys try this one if you can?
Rude. I'm doing.
So let's mark down the information we know. Figure out what other information we can figure out.
Oh, do you want to by ourselves?
Yes. Let me try example B. something we like to start with is to say, what information do we know? So what's something we do know? Okay, James Van Stevens? Okay, we know that J and M are congruent, both 31 degrees. Okay, what's another piece of information that we do know? Okay, Rachel?
Side JL,
Very good. Side JL and side PM are congruent, they have the same measure, 62. Okay. Do we currently know anything else? No. Okay, and then we say, what can we figure out? We can figure out the third angles, right? Okay. By adding the other two out, subtracting from 180. Did anybody figure out what angle K was?
Yeah.
Okay. Grade, what did you got? 39 degrees. Okay. Did anybody figure out what angle P was? Okay, 111. Now, what do we notice, guys? Those 111 and 110 is not the same thing. 38 and 39 are not the same thing. So are these triangles even congruent?
No.
No. So not only we can even say, we don't have to say not enough info. We can say they're not congruent because those angles aren't congruent. So not only do we not have enough info, they're actually not congruent. We have enough info to say they're not even congruent at all because corresponding angles are not congruent. Okay. Kevin.
So could we say not congruent because 111 is not equal to 110?
Yeah. Excuse me. We have a reason there. 111 is not equal to 110. You could do angle P is not congruent to angle L. 39 is not equal to 38. Angle K is not congruent to angle N. Corresponding angles are not congruent. Okay. Any of those would work very well. Okay. Questions on that? Okay. I want to briefly go over this one together on example C. Okay. Do we currently have enough information to prove?
Yes.
Okay. Because well, if we do one more thing.
Yeah.
What's our one thing we have to do?
Right angle on the
Right angle here to match. Now do we have angle side angle?
Yes.
Yeah, okay. Now, could we also do one more step and then have another way to prove?
Yeah.
What's the other step we can do?
Reflexive property.
Reflexive property, AD is congruent to itself. Now could you also prove by one other method? Side angle side. So we can prove by two different methods here, right? Now, do you think there's a right answer? Okay, there's not a right answer, okay? Either one you want to prove by is perfectly fine by me, okay? So sometimes there's multiple ways to prove these triangles congruent. That's awesome, okay? Any question on that? Okay. So I'm not actually going to have us go through the rest of that one, but I just want to talk about that there could be two different ways, okay? So example A right below on the kind of the more proof style ones where we're just given things, having to mark them, and going from there, okay? Let's write down after let's forget. What's something we can mark on example A here? Okay.
Finishing this packet.
Yep.
Wow.
Okay. What's another thing we can mark? Yeah.
From there we know, the other angles are congruent to each
Okay,
other.
we know the third angles have to be congruent by third angles theorem. Okay. Do we have enough to prove the triangles congruent yet? We do.
Sure. Oh wait,
Can
no.
we do one more thing?
I have it on.
QP is congruent to itself, right? By the reflexive property. Now do we have enough? Yeah. And we can do it by what method? Angle, side angle.
That's the same thing.
No. Angle, side, angle are different. The side is between two angles. Whereas angle, side would not be included. Yes, that is the difference that you need to make. Okay. Let's look at I keep saying number. Let's look at letter B. Yes, number B. What's one thing we can mark? A and C are we're given that. What's another thing we can mark? Okay, we have vertical angles here at E. Angles that are opposite each other. They have lines make a straight X.
E is the midpoint of AC.
Okay, oh yeah, excuse me, two arcs there. Thank you very much. They're not here. The other ones. Okay, so the third angle theorem, we can do angle B and angle D as well. Okay. Now, what other information are we told? I heard someone say a moment ago.
It is the midpoint of AC.
E is the midpoint of AC, so AE and EC are correct. Now, do we have enough information?
Yes.
Yeah, by what method? By angle side angle. Very good. Using angle A, side AE, and angle E. triangle AEB is congruent to triangle CED by angle side angle. We said, hey, we don't even need to know the other two sides because this is enough information. Okay? And technically, angle side angle, we really know all three angles. We don't have to say that we know all three. It's implied. If we know two, we know the third. Okay, question on that? Okay, on a problem like C, what would be a good thing for us to try, guys? Split the triangles, right? We talked about that. Now let's make sure we know which triangles we're talking about. We really see three different triangles here. The triangle JML. Okay, so let's draw that out over here. JML. Okay, and then triangle KLM. Now, what information are we told? JLM is congruent angle KML. Okay, that's one from each triangle once you split them. Hey, see me, let's back up a second. Does anybody have questions on how we split the triangle, why we split the triangle, why the drawings are this way, how we knew they were this way, any of that about the splitting the triangles? Or didn't ask or should ask? Make sure we're all on the same page there. That's an important concept. If you don't get it, you'd be very confused. Alright, so then we know that piece of information, and we also know there's another piece of information. You know what other two angles are congruent?
JML is congruent to KL.
Yeah, we also know an angle KML, which JML is congruent to angle J. Man, I just messed up so much there. I said like jangle.
Jangle.
It's kind of bad. It's really bad. It's a big oof. Okay, what? Do we know the other angles are congruent?
Yep.
Okay, by third angles theorem. Very good. We learned it in section 5.2, 5.3. We learned it in 5.3, a couple pages ago. We go one step forward. Section 5.3. The two angles of one triangle are congruent to two angles of another. Third angles are also congruent. Have to be. Okay. So now, do we know anything about the sides though? Because we said just the angle is not enough. Okay, let's maybe go back to the picture of together. What do we notice about one of the sides?
Oh, they're sharing LM.
They're sharing LM. So that's congruent to itself. They're sharing LM, so it's congruent to itself. Angle side angle, very good. So angle or triangle JML is congruent to triangle KLM. Yes, by angle side angle.
This wasn't so long.
Honestly, it's just shorter than the.
I like it when my younger one page.
Question on that?
Why is this on the page?
One page.
Okay.
Wait, we're doing all of this today?
Yes.
Okay. So a moment ago we talked about two angles and a side between them. Let's change this up. Let's say Braden liked this idea earlier. He kept trying to bring up, what if we had two angles and the side that wasn't between them, and one of the sides that wasn't between them instead? Well, okay, let's try it. Let's try it with this side and this side. Okay. Is there a way we can manipulate this triangle where it's not they're not congruent?
No.
Okay. Because we're seeing angle side, but we haven't been given that one yet. Okay.
But we can just use it.
Yeah, but we can see it. Yeah, probably not.
It's a thing, so it's there.
Okay. We can try to make this line longer.
Wait, what do you mean? Very learning.
Yeah, but then that side is.
Yeah, because we can't change these. We can't change this side and this side because they're marked as congruent. We're saying let's just say those stay congruent.
I just want to say that.
If I make this longer, does that actually change the triangle?
No.
No, and I have to keep the angle the same, so I can't swing it. Okay.
There's nothing you can do.
And I can't do anything with this one, can I?
No,
Because these angles have to stay the same. And I can't make it longer or shorter or change anything. So what are we noticing?
Hey, you can't change it.
Okay, wait, hold on.
Okay, no, what do you think?
Don't, when you have those angles like that, can't you make the other one congruent as well?
That's a great point. I was hoping somebody would bring that up. So when we have these angles like this, we can all say, hey, guess what, guys? These third angles are congruent. So is angle side secretly the same thing as angle side angle? Yeah, they're secretly the same thing as each other. Okay, so really, anytime you use one, you could use another because of the third angle theorem. Okay.
Wait, actually, that's not what I was saying. But
Oh, what were you saying?
those two angles, if they're like that, don't mean that you can't have another marking on the other side.
That's
Oh,
Oh, wait,
so
that wouldn't do
that'd be
it.
if these two were down. Yeah, I get what you're saying now.
Just
Okay.
kidding.
So here we could actually use both angle side angle and angle side. So angle side, so two angles, and the non-included side is also enough information. Which brings us to AAS, angle side,
We can just skip over.
where it says that two angles and a non-included side of one triangle are grouped to the corresponding angles and non-included side of another triangle. You have to make sure that it is the corresponding ones. Okay, it can't be two different non-included sides. It can't be two different non-included sides. Like if I were to go back a moment and look at where our hypothetical here, if instead of having this side congruent, I had this side congruent, those triangles wouldn't be congruent. That would not be enough information now. But it has to be the same side, same corresponding side there. Okay. Question on that? Okay. Hey, do you guys remember doing parallel lines cut by a transversal last chapter? Okay, you guys love that. Okay, we're going back to that a little bit. That comes back as a reoccurring theme in geometry. Okay, those two parallel lines cut by a transversal is a big reoccurring theme in geometry. Okay, so we're given here that line or segment AC is congruent to segment EC. So let's go and mark that. And we're also told that line M is parallel to line N. Let's go and mark that with an arrow. Now, if we kind of look here with these two parallel lines cut by two different transversals, we kind of see what in these shapes?
Triangle.
Triangles. You see two triangles there. And we're trying to prove the triangle ABC, this bottom triangle here, is congruent to the triangle EDC, this top triangle here. Okay. Well, two parallel lines cut by a transversal. What's something that we could know about some of the angles? Okay, we know vertical angles. That's regardless of it being a transversal or not. Awesome vertical angles. So those two on angle C, angle ECD, and angle ACB are congruent to each other. 100% of the time. Alyssa. Okay, why? Okay. So alternate interior angles. Okay. Yeah. So they're alternate interior angles because if we look at the parallel lines, they're both interior, and they alternate sides of the transversal. Okay. So they're alternate interior angles and thus are congruent because the lines are parallel. So what? Yeah, you can do that to A and E as well with the alternate interior angles or by third angle theorem at this point. So now, do we have enough to prove these triangles congruent? Yeah. And how many methods could we actually use? Two. What two could we use? Angle side angle and angle side. Because if we look here, we have you can go angle side or angle side, or you can do angle side angle. Okay. So either one you guys want is fine by me. Triangle ABC is going to triangle EDC. Unless you must rinse out after, let's forget. And I'm going to do angle side just because that's what we're talking about in this subsection.
Okay, can we skip to?
What?
Okay, how about that? Two's actually kind of fun.
I don't think so.
It took us
It's just
30 minutes to
next
go
page.
through one thing.
How about we'll do two, but we'll skip three?
I can live with that.
Okay, good, because you're going to have to.
Yeah, how do you find that?
Okay. So what's one thing we're given?
Wait, they're not.
A equals D.
Angle A is equal to angle D. Okay.
Wait, but there's no proof in there, so does that mean they're not?
Okay. I do want you guys to try and prove triangles congruent here. And there's actually I would say 3 different methods you can use in this one. I want you guys to try and see if you can get this. Okay? I want you guys to see if you can get one of these methods.
Oh, I know it.
Wait, I don't, but they're.
Oh, got it.
Yeah, I know it.
Sorry. Not here.
Wait, but I don't know how to prove that.
I'm stupid.
Straight. Take out this distance. No, we do that.
Oh, wait, so it's still like. Wait, you also know
Oh,
this
because
is half?
Yep.
Oh, okay.
Yep, because we're in the
It
quarter.
tells you that the angle. So
No,
then-
I was, I did notice that you
Well,
were.
I don't even know if I was allowed to do that.
Yeah, so.
Or you can mark some information on your picture though. So mark them if they're there. Mark them. Yep. Okay, so what's one piece of information that we can figure out here? What's one piece of information we can figure out, Riley? Oh, okay. Let's go with Sarah.
EF is equal to BC.
Okay, how do you know that?
Because if you count the boxes, it's 3 and 3.
Yeah, if you count them, they're both 3 and 3, okay? Taylor, can you mark one piece of information you know?
Yes.
You suck, but I'm not shouting.
Pass it on.
But how did you get that?
It's a right angle.
But what told you that?
The lines.
Slightly off, you don't know.
But no, because it's on
What if it's
That's
slightly
hard.
off?
Yes, it was.
right angle. You haven't learned anything. I wonder what.
Okay. Yeah, so we know those are right angles. We can only know that because it's in the coordinate plane, okay? If it wasn't in the coordinate plane, we wouldn't actually know it's a right angle. But because it's on the coordinate plane, we can tell it is a right angle, okay? What's another thing we can know here, guys? Okay, Kevin?
The length of A and B and B and E.
Okay, and they're both what?
4.
4. So they have to be congruent. Okay? And what's one other thing we can actually know?
The last angle.
Okay, the last angles, right? Those angles have to be congruent by third angle theorem. Actually, would be 2 tick marks. Okay? Unless you must raise on that, let's forget. So we have a few different methods at our disposal here, okay? So somebody give me their congruent statement that you did.
Angle, or no, triangle BAC is congruent to EDF by NSA.
Okay, we could use angle side angle. Okay? We could use angle side angle if we wanted. Okay, we could do 2 angles in the included side, 2 angles in the included side. Okay? What's another method we could use? Sarah?
AAS.
Yeah, angle side. We've done 2 angles in the not included side. Okay, what's another method we could use? Kevin?
Side angle side.
Side angle side, 2 sides in the included angle here.
Why
Because
is
we know there's 2 sides.
Why is it?
Oh.
Thanks.
They wrote it wrong. Okay. So those are 3 different methods we could use. We could use all the methods we've learned this morning. James, keep it to yourself, please. Okay. Yes, Kevin.
Since you know 2 of the lines are congruent to each other, could you also find the third one or no?
Because we already know the triangles are congruent, we can now. Because we can say, oh, if the triangles are congruent, the corresponding parts have to be congruent. Otherwise, we have a right triangle here. So something we haven't learned yet, but you guys might know it. Otherwise, this is the Pythagorean theorem. So you guys could use that to find the triangles to be congruent, or find the sides to be congruent. So and then use side, side, side. But as of right now, without using the Pythagorean theorem, no, but you could use Pythagorean theorem. It's a right triangle. Good question. So number 3, we're not doing it. Okay. Let's go on. Now let's talk about this method here. Okay. We're gonna say, let's say we have a right angle. Let's go back here again.
I forgot what hypotenuse was.
Okay. Hypotenuse is what, guys?
The other side is not the legs.
It's the longest side of what kind of triangle?
Oh,
A right triangle. It's the one that's not the legs. Where is it located on a triangle?
Side.
It's kind of diagonal to the right angle.
It's diagonal. It's opposite the right angle. It's diagonal or opposite to the right angle.
That's
Okay. So let's say here we have what kind of triangles I just make? A right triangle, didn't I?
Well, not yet.
Okay. Maybe it's totally a right triangle.
Mark it, otherwise it's not a real
Oh, that's fair. That's a good point. I like it.
That is definitely.
Oh my goodness.
We're not.
Okay.
Not to crush your hopes and dreams and everything.
Cool. I mean, I think you always want to try to do.
That's true. I'm not gonna lie.
I'm not gonna lie to you on this one.
Alright, you know what? That's not cool.
Is it?
I'm a right-handed person.
I'm a right-handed person.
Ah!
Okay. Okay. Now let's say we have right triangles here. Okay. Now let's say. If I know these two sides are congruent, is that enough to prove them?
Yes.
By what?
Side angle side.
Side angle side. Okay. Let's say I know one of those legs, but I don't know the other one. Okay. Is that enough information to prove it?
No.
Okay. No, we can still alter some stuff, right? We can still alter some stuff. As of right now, this angle could still change, and we can move this one up too, and it kept those the same. It's still a right angle. It's still a right angle here, and it's still congruent there. So as of right now, those things can still change. Okay. What about if I say I knew this angle? Is that enough to prove now?
Yes.
Yeah, because we have angle side angle, right?
Yes.
Okay. Or if I said instead of that angle, maybe I do this angle. Okay. Well, that's once again angle side. Okay. I'm gonna use certain angle standards to do angle side angle as well. So what if I knew one of those legs, but I also knew the hypotenuse?
Yes.
Yeah.
Okay. Is that one of them so far? Do we have a side angle?
No.
No. Okay. We haven't heard of this one. But are we able to manipulate this to where we don't change the hypotenuse? We don't change this, because then we can't change this angle if these two are locked in, can we? Okay, because if we try and change this angle, then all of a sudden we're changing the right angle. Try and change this, then all of a sudden we're changing the length. We don't want that. Try and change this, or to move it up, well then we'd be either adjusting this length, or this isn't even part of the triangle, or I move the angle, or make it to not even a triangle. So can I even adjust that in a possible way?
No.
No, okay. And then second level with that, Pythagorean theorem, the two legs squared and added equals this one added. So if we know two of the sides of a right triangle, you can always find the third. So if you know two, you can always find the third, and it has to be congruent based on what these two are, okay? Talk about that more actually later in depth. But for now, this is another special one where it's only for right triangles, okay? It's only for right triangles here. Okay, and it's called HL, hypotenuse leg, okay? Now, why do you think this might only be for right triangles?
Because I saw series and.
Because only right triangles have the hypotenuse, okay? Only right triangles even have the hypotenuse. No other triangles even have the hypotenuse, okay? Just right triangles do. Okay? So here, hypotenuse and a leg, and then congruent to the hypotenuse and the leg of another triangle, okay? So once again, here's the diagram saying which one's the legs, which one's the hypotenuse here, okay? Can I put it away, please? Okay. So let's look at these two examples. In this letter A, we have what kind of triangle here? Right triangle and a right triangle, okay? What might be helpful for us, guys? Split the picture.
Whoa, wait.
That is definitely not right triangle. Oh, okay, yeah.
That's a great right triangle. Never been more
Thanks.
impressed.
Okay, thanks. I knew it. Yeah, Sarah, what did you say? Well, what is up with Z? Do we really even need that Z there? No, it's just to confuse you. Okay? Now, do we know enough information currently to prove these right triangles congruent?
Yes.
No.
No.
Okay, no, we can fill out one more thing. What else can we know?
WX is congruent to
WX is congruent to itself. They share this side. So now what can we use to prove them congruent?
Angle was the- No, side
No
angle.
sides.
Do we have a side-side angle?
But it's technically the same plot.
No, but we have hypotenuse leg. It's a special one. Triangle. We can call it number of things. Call it VWX. Is congruent to triangle. Let's see, YXW by HL, or hypotenuse leg. Okay. We do not have a side-side angle. Okay, but we do have hypotenuse leg for right triangles. Okay. Kevin.
How did we find the bottom one with the two tag marks?
Yeah, because WX is the same thing itself as the reflexive property. It's just when we split it, sometimes we forget that. We have to look, oh, WX, WX, that's the same thing. So it can be helpful to look back to the original picture or stuff like that. A lot of times when we have overlapping guys, a lot of times when we have overlapping triangles, we have to look back and say, oh, did they share anything? Great question. Okay. Let's look at example B here. J and L are right angles, and K is the midpoint of JL and MN. So K is the midpoint of two different things, JL and MN. What can we mark on that then?
So we know that JK is congruent to KL.
Okay, JK is congruent to KL.
And MK is congruent to KL.
Yeah. Do we have enough to prove these already?
Yes.
Yeah. By what? By hypotenuse leg. Okay. We don't have a side-side angle, but we can do a hypotenuse leg. Now, could you also go one step further and do vertical angles? Then you can do side angle side or angle side angle. Then you can walk about. Okay. So triangle JKN is congruent to triangle LKM. By hypotenuse leg. Can you also use what? Yeah, you could use angle side. Yep. Could use that. Yeah. Okay. Questions on that? Okay. So let's talk about some that might not work. Okay, we talked about a bunch of them that did work. Okay, let's talk about a couple that might not work. Okay, let's say we don't have a right triangle. We no longer know that this is the right triangle. Now, is all of a sudden having these two sides and this angle? Our question is that now enough? Okay.
You're horrible.
Okay. No, we don't have any more angles because look at what I can do. Okay. Right now, everything about these triangles are the same. Let's say I added this, and I don't change the length. Am I able to change this angle? Yeah, it's not marked. Okay. And so I could do what? I need to do something different there. What do I need to do different there? Oh, okay. Excuse me. That needs to stay the same. Let's say I moved. What was it? Oh, I had it. What was it? This thing needs to stay the same. Now I'm blanking on it.
You need to make the slide longer.
Yeah, if this side goes longer, we're good with that. Then we need to change that angle somehow. Alright. No, there it is. I'm trying. I'm linking right now. Okay, I'll get back to you guys later on it. I remember. I'll get back to you guys later. It's gonna pop up. I'm just gonna remember out of nowhere. I'll be like, oh, this is why, by the way. Okay. So we learned 5 different methods, 5 different shortcuts to prove triangles congruent. We learned 5 different shortcuts to prove triangles congruent. Okay. We learned side, 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 angle, 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 side, hypotenuse leg. The 2 that we didn't learn, 2 combinations we didn't learn, side, side, angle, and angle, angle, angle. We said why angle, angle, angle didn't work. I'm gonna get back to you on side, side, side. I just have to remember. I'm blanking right now. Not proud about it. Happens. Okay. So we can't use those. Here's a way to remember it. Angle, angle, angle doesn't work because you always have to have at least one side. Side, side, side doesn't work because we don't like naughty words, even if they're rearranged. Okay, we're gonna leave it at that. Okay, so that's the way I like to try and remember that those two don't work. Side doesn't work because it's a naughty word if you rearrange it. We don't want that.
That means
Okay.
SAS.
Seriously, why?
That means SDS.
No, it's not seriously why it doesn't work. Like there's a reason why it can't work. I'm just blanking on what it actually is right now. The demonstration.
Oh, right.
If that's the case
Yeah.
on SAS.
But-
it can't work.
What?
Okay, if you flip a word in
Okay.
between,
Okay, we talk. Okay. So angle doesn't work either though because you have to have at least one side. Okay. So, is it possible to prove these two triangles are congruent on this first one?
Not right now.
No, because all we can know is the third angles. And can we know anything based upon the angles?
No.
No. Okay. So no, because there's no angle. Okay. There's no angle. Okay. What about the next one? Oh, also, excuse me, I have a typo on, it's kind of like a formatting typo on yours, okay? Where do you notice your AAA is listed, guys? It's like listed like right down here, isn't it?
Yeah.
That's really awkward, okay? It like spaced out awkwardly, then I fixed it after I printed it. So go ahead and cross that out there and just rewrite it up here, okay? Just so that way you don't get confused later and think, oh, we can't use that one, okay? So go ahead and cross out this angle that's below this. And write it up there again, okay?
What are these triangles?
That means it's parallel.
Yes, these are parallel lines. Yep.
Why would these be lines? Wait, question.
What do they put? What?
Lines.
Oh, that's congruent. Yeah, parallel. They never touch. Yeah.
Number one shares a side though. So would that one be congruent?
Number one does not share a side.
What do you mean?
We don't know that S is the midpoint of HM.
They're literally.
Yeah, but we don't know. They share a point. We don't know they share a side. Like sharing a side would look like this, where they literally have the same side. On the bottom there.
But they do. Literally T and W, they're just it's one line.
Can you mean?
As I said before, we don't know this. Maybe I can see it.
Okay. Does that make sense?
No, it doesn't. I mean, literally, that
It
Isn't that
doesn't
one line?
say that, you know how in
Yeah, this is
religion
all one
exclamation
line, but it's
line.
split, and we don't know if it's split in the middle or not. On other problems, we were told it was the midpoint. Here, we don't know where it is.
But if it wasn't, then wouldn't the angles change?
No, not necessarily. Because we could have it to make it more dramatized. I'm not even clicking the thing. Okay, and have it more dramatized. Okay. I didn't dramatize it before. Okay, have it more dramatized here.
This is literally hurting my brain way too much.
So those angles could still all be congruent.
But they still share a line.
No, they
But
don't.
now
not
those are
the
definitely
middle.
not congruent.
They share a point.
So I just like expand the bottom triangle just to make it more exaggerated.
Okay, the top half is.
Okay, I see it. I see it now. I see it now. Show people.
We're actually going to
Can you just skip it?
Come on.
we're gonna look at this example and we're gonna be done, okay? So do we have enough to prove this congruent?
Not right now.
Not right now,
but
but could we figure out more?
Yes.
Okay, so right now we know one set angles. What else could we know?
They share the middle line.
They share the middle line.
And then the other equals the L and the N, the other ones on the other side, aren't they?
How do we know that?
Because they're the midpoint. The midpoint. No, not midpoint. I don't know. There's a reason, and I
So
just.
as to do with these parallel lines,
Interior.
Wait, they're-
alternate interior angles, two parallel lines cut by a transversal, alternate interior angles are then congruent. Now could we prove these congruent?
Yes.
Yeah, by angle side angle.
Yep. Also, Mr. Cross, can I have a review? If it won't be on Monday.
Well, you won't be here on Monday.
Wow.
Yeah. I'll get it. Yeah, we're gonna skip the third one. We're gonna skip the back for now. I would cross them out. We're gonna skip them for now.
Yeah, it does.
No, I'm sorry.
You didn't jump over it.
Oh my gosh. Did you do it on purpose?
No, I just totally realized it. Cause you like half. Thanks for that, Mike.
You're welcome. Thanks for giving me a trip hazard.
You're, gotta keep you on your toes, Mr. Councilman.
Well, see, but tripping me would do the opposite of that.
How do you manage to run this over so much?
Yeah, that was good.
I'm so mad.
Wait, so are we skipping any of this?
No. I mean this time. Okay. Hey, on numbers 1 through 9, what's the special instruction it says on numbers 1 through 9, guys?
Only use ASA, AS, or HO.
Yeah. So 1 through 9, only use the new 3 from today. Only use the 3 new ones from today. Then on the back, 10 through 15. Okay. 10 through 15. Those can use any of the 5 we've learned. Okay.
Is it weird to go get a blizzard when it's like literally freezing out?
No, because blizzards are good.
I'm hungry.
As long as you're eating it for one.
Yeah, that's fair.
As long as it tastes good.
I think that's